In 2017, NASA made a promise to humanity. They would return American boots to the surface of the moon by 2024. Then it became 2025, then 2026, then 2027. And quietly, without announcement, without press conference, without fanfare, the mission itself changed. Artemis III, the mission that was supposed to plant human footprints on the lunar South Pole, was restructured into something else entirely. Not a moon landing, a test flight in low Earth orbit, and almost no one noticed. The most expensive space program in human history just quietly abandoned its own primary objective. Why? This is not a story about failure. This is a story about something far more unsettling. It is a story about how the most powerful space agency ever built, armed with over $100 billion, the most advanced rocket ever constructed, and the full force of American technological ambition, is discovering that the moon is harder than they remembered. And while America recalibrates, China is not waiting. China has set a date, the year 2030. And they intend to keep it. What you are about to see is the story of humanity's second attempt to conquer the moon. It is a story of breathtaking ambition, terrifying complexity, and the very real possibility that the nation which walked on the moon first may not be the nation that claims it. The Artemis III crisis has begun, and the clock is running. To understand what happened to Artemis III, you need to understand what it was supposed to be. The plan was elegant in its ambition. An Orion spacecraft would launch aboard NASA's Space Launch System, the most powerful rocket ever flown, and carry 4 astronauts not just to the moon's orbit, but to its surface. For the first time in over 50 years, human beings would walk on another world. And not just anywhere. They would walk at the lunar South Pole. A place no human being, no robot, no probe has ever touched. A place of total darkness, of billion-year-old ice, of secrets buried so deep that even the sun has never found them. But then, engineers looked more closely at what they were actually asking, and what they found made them stop. SpaceX had been contracted to build the Lander, a modified Starship that would carry astronauts from orbit to the surface. But Starship had never completed a full orbital flight with crew. It had never demonstrated refueling in space. It had never proven it could land on the moon. It needed, according to some engineers, as many as 16 separate refueling launches just to fuel up in orbit before heading to the moon. 16 launches, each one a chance for catastrophe, each one a dependency in a chain that, if broken anywhere, ends the mission. And the spacesuits were not ready. The suits NASA was counting on, the Axiom Aximu, had failed their preliminary design review. They consumed too much oxygen, too much water, too much power. They were too heavy. Collins Aerospace, the backup contractor, had already walked away. NASA was now dependent on a single company to build the only suits that could keep human beings alive on the most hostile terrain in the solar system. And NASA's own Inspector General looked at all of this and issued a stark warning. Spacesuit readiness, 2031, at the earliest. NASA quietly made a decision that will shape the next decade of human spaceflight. Artemis III would not land on the moon, not yet. Instead, the mission was restructured. The crew would launch. They would rendezvous with commercial hardware in low Earth orbit. They would test the docking systems, the life support, the procedures. And then they would come home. NASA pointed to the Apollo program, specifically Apollo 9, as precedent. Apollo 9 never left Earth orbit either. It tested the lunar module docking in low Earth orbit. And it was that mission that made Apollo 11 possible. The logic was sound. The reasoning was defensible. But the calendar wasn't defensible at all, because while NASA was being methodical, China was accelerating. There has never been anything like SpaceX's Starship. Standing nearly 400 feet tall, it dwarfs everything humanity has ever launched. It is larger than the Saturn V that carried Apollo astronauts to the moon. It is designed to carry more payload than any rocket in history, and it is powered by 33 engines, 33, firing simultaneously at liftoff. No rocket in history has ever done this, because no one has ever needed to. But 33 engines means 33 ways for something to go wrong. And in space, one wrong thing is all it takes. The first Starship test flights were not quiet failures. They were spectacular. The vehicle exploded, then exploded again, then caught fire mid-flight, then lost engines, then lost control. Each time SpaceX said this was intentional. Each failure was data. Each explosion was learning. And to be fair, they were not wrong. Each successive test flew higher, longer, closer to success. The iteration was real. But NASA's Artemis schedule could not iterate at SpaceX's pace, because Starship's role in the Artemis mission is unlike anything it has ever done before. In lunar configuration, Starship must first launch into low Earth orbit. Then it must wait in orbit, while a series of tanker ships bring fuel to it, transferring thousands of metric tons of supercooled liquid methane and liquid oxygen between spacecraft in the vacuum of space. Technology that has never been demonstrated, not once, not ever. If the propellant transfer fails, even partially, Starship cannot reach the moon. The mission ends before it begins. Then there is the heat shield. Starship's belly is covered in thousands of delicate ceramic tiles, each one slightly different, each one critical. During test flights, tiles have cracked, fallen off, burned through. A tile failure during moon return re-entry at speeds approaching 25,000 miles per hour is not survivable. And there is another challenge no one talks about openly. Liquid propellants slosh. Inside a rocket's tanks, fuel moves, especially during the intense vibrations of launch and the weightlessness of orbit. Engineers call it fuel sloshing, and in the wrong conditions, it can shift the rocket's center of mass fast enough to overwhelm the engine's ability to compensate. The vehicle tumbles, then it dies. SpaceX is building baffles into the tanks, anti-slosh systems, redesigned engine ignition sequences. All of this engineering is brilliant. All of it is unproven. All of it must work perfectly, simultaneously. There is a version of the future where Starship solves every one of these problems, where it becomes the most revolutionary spacecraft ever built, where it makes moon landings routine and Mars achievable within a generation. There is also a version where it doesn't, and no one can be certain which version we are in. Why the South Pole? Of all the places on the moon, the vast grey plains the Apollo astronauts walked, the ancient highlands, the dark Maria, why did NASA and China and the entire world converge on a single dark frozen corner of a world 240,000 miles away? The answer is water, or rather what water can become. The moon tilts only 1.5 degrees on its axis, almost perfectly upright, which means certain craters at the South Pole, deep, ancient craters, have not seen sunlight in billions of years. Not millions, billions. The floors of these craters are colder than the surface of Pluto, colder than anywhere in our inner solar system. At minus 230 degrees Celsius, they are among the coldest stable environments in the known universe. And inside them, preserved in that eternal cold, is ancient water ice. Water that may have arrived via comets billions of years ago. Ice that has been waiting undisturbed since before life existed on Earth. That ice is not just scientifically priceless, it is strategically invaluable. Split water into its components and you get hydrogen and oxygen, rocket fuel, and breathable air. A base at the lunar South Pole would not need to import its rocket propellant from Earth. It could manufacture it on site from the ice in the craters. It would become a gas station in space. A gas station from which you could refuel a spacecraft bound for Mars. This is why the South Pole matters, not just for science, not just for prestige, but because whoever controls that ice controls the future of deep space exploration. But the South Pole is not just valuable, It is dangerous. The terrain is unlike anything the Apollo astronauts encountered. The flat, sunlit plains near the moon's equator, where the Apollo missions landed, were almost forgiving by comparison. The South Pole is jagged, shadowed, broken. Ancient crater walls rise like shattered walls from the surface. The regolith, the lunar soil, is razor-sharp, electrostatically charged, and clings to everything. Apollo astronauts found lunar dust invasive after short surface walks. South Pole exploration could last days. The suits are not ready for that. And then there are the moonquakes. Apollo seismometers left on the surface detected quakes continuing for hours after the initial event. The moon rings like a bell, and recent analysis of that data suggests active thrust faults near the South Pole. The ground there is not stable. There is also the gravity anomaly. Beneath the South Pole, buried under 300 kilometers of lunar rock, is something massive. A concentration of dense material weighing 2 quadrillion tons. Scientists believe it is the remains of an ancient asteroid impact. It creates a gravitational pull stronger than anywhere else on the moon's surface. 2 quadrillion tons of buried mystery, and humanity wants to build a base on top of it. In 2023, India's Chandrayaan-3 spacecraft landed near the South Pole, the first human-made object to reach that surface. It confirmed the presence of sulfur, oxygen, iron, calcium, and other elements. The South Pole is real. The ice is real. The danger is equally real. The first space race was a sprint. America and the Soviet Union running flat out, burning money and lives and national prestige in a race to plant a flag on an alien world. America won. The Soviet program collapsed, and for 50 years the race was over. What is happening now is something different. This is not a sprint. This is a land grab. The nation that establishes a permanent, functional base at the lunar South Pole first will not just claim scientific prestige. It will, through proximity and precedent, shape the rules of who can go where, who can extract what, and how the resources of the solar system are allocated for the next century. The moon has no international law, no UN treaty that covers resource extraction. Whoever arrives first writes those rules. This is why both nations are running. China's lunar program, Project 921, is not a dream on paper. It is a machine in motion. China is developing new heavy-lift rockets, a new crewed spacecraft, a new lunar lander, and a new spacesuit designed specifically for the moon's surface, F-44. They have already sent rovers to the far side of the moon, something no nation had done before. Their Chang'e missions have returned lunar samples to Earth. China is not experimenting. China is executing. They have already sent rovers to the far side of the moon, something no nation had done before. Their Chang'e missions have returned lunar samples to Earth. China is not experimenting. China is executing. Their target date for crewed lunar landing 2030. NASA's current best-case timeline for Artemis IV, the actual crewed lunar landing after Artemis III's restructuring, late 2028 to 2029. The margin between those dates is not comfortable. It is terrifyingly thin. And if Artemis IV encounters the same kinds of delays that have plagued every previous Artemis mission, the same budget overruns, the same supply chain failures, the same technical crises that pushed the first landing back by years, China will not wait. The two programs are building competing international coalitions. NASA has the Artemis Accords, a framework for peaceful, transparent space exploration signed by over 30 nations. China has the International Lunar Research Station, a parallel initiative developed with Russia and other strategic partners. Two visions of the lunar future, two sets of rules, two coalitions, each building toward the same South Pole. And there is room for only one first base. Every delay in the Artemis program is not just a technical setback, it is political ground ceded, geopolitical positioning lost, a future being written without America's hand holding the pen. There is one more dimension to this race that is almost never discussed in the announcements and press releases. The moon is not the destination. The moon is the training ground. Both NASA and China are using the moon to prepare for Mars, to test life support that can operate for years without resupply, to practice resource extraction in a hostile environment, to learn how human beings survive far from Earth. The real race is not to the moon. The real race is to the red planet. And whoever wins the moon wins the inside lane to Mars. The Artemis program costs $4 billion per launch. Not the total program, not development costs, not the decades of engineering, not the contractors and the subcontractors and the subcontractors of the subcontractors. Just the single act of launching one rocket once, $4 billion. The total program cost, including development of the SLS rocket, the Orion spacecraft, the ground systems, the commercial landing systems, has crossed $100 billion. And the Government Accountability Office has explicitly stated that senior NASA officials view the current SLS framework as unsustainable. Unsustainable. A word applied to a program that is supposed to carry the future of human civilization beyond this planet. Part of the reason for that cost is a decision made by the United States Congress. When the SLS rocket was designed, Congress legally required NASA to use components and supply chains inherited from the Space Shuttle program, parts that were already manufactured, contractors already employed, infrastructure already built. This was not an engineering decision. It was a jobs protection decision, and it built its cost structure into the DNA of the most important rocket America has ever made. Every month that the program delays, every technical setback, every spacesuit problem, every Starship test failure, the overhead continues. Thousands of engineers and contractors on retainer, hundreds of millions of dollars burned not on progress, but on maintaining the capacity to make progress. Time is money, and in the Artemis program, time has been extraordinarily expensive. There are voices in Congress, growing louder with each delay, who want to cancel the SLS entirely, to pivot completely to commercial launch providers, to hand the moon mission to SpaceX and Blue Origin and walk away from the government rocket. And it is here that the crisis deepens, because Blue Origin, one of NASA's 2 commercial landing system partners, recently suffered a major static fire explosion that severely damaged its launch infrastructure. The backup is broken. NASA is now structurally dependent on SpaceX, and SpaceX, brilliant, audacious, revolutionary SpaceX, has never flown humans to the moon, has never landed on the lunar surface, has never demonstrated propellant transfer in orbit. If the SLS is cancelled, NASA has no alternative lunar transport ready. If SpaceX's Starship encounters another critical setback, NASA has no plan B. America's return to the moon rests on a single supply chain, a single rocket, a single company. And if that chain breaks, if the wrong thing fails at the wrong moment, there is no fallback. There is no rescue plan. There is only the question of whether China will walk on the moon before America returns. And there is one more thing, one risk so serious that NASA's own Inspector General named it explicitly. If astronauts land on the moon's surface and something goes catastrophically wrong, if the ascent vehicle fails, if the habitat is breached, if there is an emergency that requires immediate evacuation, NASA has no rescue plan. There is no second vehicle on standby, no backup lander waiting in orbit. If astronauts are stranded on the lunar surface, the current Artemis architecture has no mechanism to bring them home. This is the true weight of the Artemis crisis, not just delays, not just cost overruns, but the possibility that humanity's most ambitious return to another world carries, in its current configuration, a risk it has not yet found an answer for. In the summer of 1969, a Saturn V rocket carried 3 human beings beyond everything humanity had ever known. They traveled for 4 days through a void that is not really empty. It is filled with radiation and silence and the slow drift of time. And then 2 of them climbed down a ladder and stood on the surface of another world. One of them said, "One small step for man, one giant leap for mankind." He was right, but perhaps not in the way he meant. The giant leap was not the step itself. The giant leap was the belief. The belief that a species that had only recently learned to fly, that had spent most of its existence fighting over patches of soil and squabbling over its own borders, could look up at a light in the night sky and decide to go there. That belief did not die when the Apollo program ended. It went quiet. It retreated. It lived in textbooks and museum exhibits, and the memories of people who watched those first footprints on a black and white television in 1969 and felt something vast and wordless open up inside them. What Artemis represents is the attempt to revive that belief, not just to return to the moon, but to build something permanent there, to stop visiting and start inhabiting. To take the species that has only ever known one world and teach it, finally, to live in more than one. That is why the delays hurt. Not because of the money, not because of the geopolitics, but because the dream has been waiting long enough. The critics are not wrong. The SLS is expensive. The spacesuits are behind schedule. Starship is unproven. The rescue plan does not exist. China is gaining, and the margin for error grows thinner with every passing month. But the critics, with all their spreadsheets and audits and political calculations, are sometimes blind to something that cannot be measured in dollars or launch windows or geopolitical advantage. There is a version of humanity that stays here, that never goes back. That decides the moon was a historical curiosity, visited once, visited briefly, never claimed. And there is a version of humanity that goes. That builds a base in the shadow of a crater that has not seen sunlight since the dinosaurs walked this earth. That extracts water from ice older than life itself. That fuels a spacecraft bound for the red planet from a filling station on the moon. That plants the first seed of a civilization that does not end when this planet does. Artemis, despite its crises, despite its costs, despite the very real possibility that it will stumble before it succeeds, is humanity's best current attempt to choose that second version. Somewhere above us, right now, the moon hangs in the dark. It has been there for 4.5 billion years. It waited while life learned to crawl, while it learned to walk, while it learned to sail and fly, and finally, to leave the atmosphere of the world it was born on. It is still waiting, patient, permanent, ancient beyond understanding. The only question that has ever mattered is not whether we can afford to go. It is whether we can afford not to.